Hello and welcome to next segment 3 of video training overview of hyperspectral imaging technology. In this presentation, I will go over Headwall, diffraction, grating, and hyperspectral systems. What is a grating? A diffraction grating is an optical component with a periodic structure which splits and diffracts lights into several beams traveling in different directions. The emerging colorization is a form of structural colorizations. This slide shows its diffraction order and grating. As you can see, zero order and first order. And grading disperse color according to this formula, the sign, the angle of incidence, the angle of diffractions, the order number, wavelengths, and so on. This slide here shows the overlapping diffraction orders from grating. If diffraction orders overlap, long pass filter is required. Look at the diagram, see the first order diffracted beam and second order diffracted beam. Here's a chart of the diffraction grating efficiency curve. It shows the FM sphere grating efficiency, design simulator profile and measure efficiency. The Headwall advantage. We make gratings. We're the world leading manufacturer of original master diffractive optics. We do concept, prototype, high volume manufacturing, optimize application specific instrument and sensors. Complete grating the design for micro hyperspec Gen 2. With the OEM application specific spectral products. Components to system. Our OEM instrument range from gratings to spectral engine to fully integrated subassemblies that drop into a larger instrument. Our fully integrated spectrometers are soup to nut system like the one that you are working with here. You see the spectral image products. You have the HE hyperspec, the nano hyperspec, micro hyperspec. In this slide, it shows the Omner is designed to re-image the slit onto the camera with very little smile and keystone distortion. The grating is placed at the center of Omner to disperse the colors that pass through the slit, so that each color is re-imaged in different spectral location on the focal plane. And with our all-reflective design, we can produce the same distortion-free images from the UV to IR by just changing the coatings and the gratings. Here is the Aberration corrections. You want an image with no distortion, so that every pixel in the slit is mapped to columns of pixel on the focal plane. No serious calibration math needed to fix the data, and we get this mostly for free in Omner. In competing system, you will see keystone and smile distortion. Keystone stretches one end of the spectral data, mixing data from one spatial channel into the next. This is hard to correct for, and you don't want to have to do in software. SMILE's distortions changes the wavelength registration between the ends and the center of the slit. SMILE is easy to calibrate out, but if you don't have to, your data is much more reliable. Headwall, concentric spectrograph, and aberration corrected gratings result is practically no keystone or SMILE distortion. Here we have an image with aberration correction. You can see the sharp focus across wide field of view. To the left, you have no aberration correction, and to the right you have aberration corrected. So aberration correction sounds like a silly word here, but it means a lot to saving on time, battery life, or fuel. With an uncorrected system, you have a nice focused and crisp image at the center, but as you can see on the left, the top and bottom third of the image are out of focus. Headwall's patent aberration correction imagers correct the aberration that makes the image fuzzy, providing a crisp image across the slit to reduce number of passes over scene. Here, in the spectral direction, aberration correction improves spectral resolution by fixing how different colors focus on the image plane. Without aberration correction, the yellow and blue parts of the spectrum would image with high resolution, but the red and purple light would be defocused about the camera, and the green would image inside the camera body. This means that the blues, greens, and reds would form blurry images, while the blue and yellow would be in focus. This wouldn't be a problem if cameras were made like a ditch that catches water, but they are not. Headwall uses the grating and instrument design to correct these imaging aberrations so that every wavelength comes to focus on the image plane at the same time. This evens out the spectral resolution and makes the images crisp at every wavelength. Finally, the Optical design provides a high throughput system that works up to f2.0 or f2.5. An f2 system puts 4 times more light through to the detector than an f4 system. This means that on a very bright day you can adjust the aperture stop down so that you don't saturate the camera, and on a cloudy day you can open the stop up to let it more of the available light. F2 or f2.5 system is a huge advantage in non-ideal illumination condition. The Headwall advantage summary: with the world-leading manufacturer of original master diffractive optics, make aberration corrected gratings, or reflective spectrograph, eliminate issue with transmission gratings, reduces number of surfaces requiring anti-reflection coatings, robot system design, thermal optomechanical design, experienced team of support and application engineer who contribute to next generation system designs. The Headwall advantage is the HyperSpec 3 software. Clean and convenient user interface, integrates Headwall components seamlessly. You don't really need a PhD guy to run system and collect accurate data. Support approved third-party components such as the GPS and IMU. Have a complete airborne package. This will conclude the presentation. Stay tuned for next segment 4, important in hyperspectral. Thank you for watching.